Hello everyone, welcome back to the channel Mining Engineering. I am Satyavrata. Today is the second lecture on the topic explosives. In the previous class on explosives, we have covered the introduction to explosives. You can find the previous lecture by clicking on the link given above. In this class, we will see the detonation mechanism, classification of explosives, components of explosives, and the initiation sequence. Now let's see the detonation mechanism. The first term in the detonation mechanism is ignition. Ignition is where an explosive compound is given energy. This could happen via friction, impact, heat, electrical impulse, and through many other routes. That means we are providing some external source of energy to the explosive compound to initiate the chemical reaction, and that external source of energy could be provided through friction, impact, heat, like many other sources. Then the decomposition process of the explosive compound will start, and the process are combustion, deflagration, and detonation. Now let's see what is the combustion process in the detonation mechanism. This means a chemical reaction capable of giving off heat, whether it is actually felt by our senses or not. That means when we have provided the external source of energy to the chemical compound, the chemical reaction in the explosive compound will take place, and that chemical reaction will generate some amount of heat, like a slow burning process. Deflagration. This is an exothermic process in which the transmission of the decomposition reaction is mainly based upon thermal conductivity, that means by heat transfer. This means rapid burning of material which is faster than the combustion. Here the speed of burning is, we can say, 1 meter per second. The next one is detonation. In the detonation process, the reaction time is very fast, so that the explosive compound decomposes by releasing a shock wave rather than the heat generated by the deflagration process. Now let's see theory of detonation of explosive. Let us suppose this is the explosive charge column, and we are going to detonate this explosive charge column on this side. After the detonation, the decomposition reaction initiates in the explosive charge, and the front of the reaction is called the CJ plane. This plane is called the CJ plane. Behind the CJ plane, the expanding gases are produced, and in front of the CJ plane, the shock wave is produced. And in between this shock wave and the CJ plane, this space, in this space, the reaction takes place due to the high pressure, and the reaction proceeds towards the undisturbed explosive. This part is the undisturbed explosive, and the reaction proceeds towards the undisturbed explosive like this. So behind the CJ plane, the gases are produced due to the decomposition process, and in front of the CJ plane, the shock wave is generated, and that process proceeds towards the undisturbed explosive zones. Now let's see. Yes, so this is the explosive charge, okay, and we have detonated this side, and the reaction takes place and proceeds towards the undisturbed explosives. And this is the CJ plane. This plane is the CJ plane, and this is the shock wave front. In between this CJ plane and the shock wave front is the reaction zone, and this part is the undisturbed explosives, and behind the CJ plane, the expanding gases are produced. So the self-sustained shock wave produced by chemical reaction was described by the CJ plane, the Chapman-Jacquard space. The space is negligible thickness, is bounded by two infinity planes. On one side of the wave is the unreacted explosive, on the other the exploded gases. There are three distinct zones: the undisturbed medium ahead of the rapid shock wave, a rapid shock wave at Y leading to a zone in which the chemical reaction is generated by a shock and complete at X, that is a CJ plane. A steady state wave where pressure and temperature are maintained. Now let's see the classification of explosives. So first we will classify the explosives based on their speed of detonation. We know what is the detonation. Now based on the detonation process we will classify the explosives. So one is the high explosives and other one is the low explosives. In the high explosive, the shock wave passes through the high explosive at or faster than the speed of sound in that material. Examples are TNT, PETN, military explosives. I've told you the full form of TNT, trinitrotoluene, PETN, pentaerythral tetranitrate. In the case of low explosives, the shock wave passes through the low explosive slower than the speed of sound in that material. Examples are gunpowder, some fireworks chemicals. Now let's see, this is the explosive charge column, and after the detonation, the reaction speed, the speed of reaction is faster than the speed of sound in that material. So those explosives are called the high explosives. In the case of low explosives, the reaction speed is slower than the speed of sound in that material. Now let's classify the explosives based on their sensitivity, and they are classified as primary explosives and secondary explosives. Primary explosives are very sensitive and are detonated by a spark, flame or impact. The spark, flame or impact are the ignition sources, the external energy which we have to provide to the explosives for the initial decomposition process. But these primary explosives are not very destructive. Primary explosives are very sensitive, however they are not very destructive. They are basically used to initiate the secondary or main explosives. For example, Ng, leadazite, mercury fulminate, etc. Secondary explosives require a detonation wave of considerable magnitude to detonate. That means the secondary explosives cannot be initiated by a small amount of spark, flame or impact, because they are less sensitive to small amount of external energy. They require a considerable magnitude of detonation wave for their detonation process. However, the secondary explosives releases huge quantities of energy. For example, TNT, PETN, emulsion explosives, N4, etc. Now let's see components of explosives. Most explosives are made up of certain components which are oxidizers, fuels, and sensitizers. Oxidizers, a chemical that provides oxygen for the reaction. Typical oxidizers are nitrated salt such as ammonium nitrate, sodium nitrate, and calcium nitrate. Fuels, a chemical that reacts with oxygen to produce heat. Common fuels include fuel oil, carbon, granular aluminum, TNT, black powder, or any carbonaceous material that produces heat. The sensitizers provides the heat source to drive the chemical reaction of oxidizer and fuel. Sensitizers are generally small air bubbles or pockets within the explosive. Let's see the initiation sequence. First of all, we should know what is required. The first thing is to detonate the explosives safely. The second one, for detonating the high explosives or explosives with low sensitivity. Suppose this is the explosive compound and here is the person which is lighting a match to detonate the explosives. But the situation is not at all a safe situation because the explosive will explode and it will affect the person who is detonating the explosive. It's a dangerous situation. So we need a proper initiation sequence to detonate the explosives from a safe distance. That's why we need a proper initiation sequence to detonate one explosive. This situation is completely a dangerous situation. Now let's see the situation. Here we are going to detonate the explosives and here we are lighting it. However, we are not directly providing the energy to the explosives. We have used some initiation sequence, like here each one where, and we are going to give the flame another part of the wire and it will take some time to reach the explosives so that we can move to a safe position. So for this reason, to detonate the explosives safely, we need a proper initiation sequence. Another reason for detonating the high explosives or explosives with low sensitivity. The ignition sources are heat, impact, friction, electrical impulse. However, these ignition sources alone cannot generate that much detonation pressure to detonate the high explosives. These ignition sources can detonate a high sensitivity, low explosives. However, in the case of high explosives, these ignition sources like the heat, impact, friction, they cannot alone generate that much amount of detonation pressure to detonate the high explosives. That's why we need a proper initiation sequence to detonate the high explosives. Some basic initiation sequence like this. We're going to detonate the base explosives and the sequence are safety fuse, ordinary detonator, detonating fuse or shock tube that will initiate the base explosives, like the exploder, electric detonator, detonating fuse or shock tube and the base charge, lugger, electronic detonator and the base charge. Okay, we'll see in the next class what are the type of detonators like the ordinary detonator, electric detonator and the electronic detonator, and the type of connecting wire like the detonating fuse, shock tube, etc. in the next class. In the next class we'll cover the basic blasting accessories. Okay, thank you.